In this quick video, I'm going to show you the difference between a Bohr model and a Lewis dot. Bohr models you've actually learned how to draw in middle school. Okay? And so I have three examples here. I have lithium, which is element number 3. I have nitrogen, which is element 7, and sodium, which is element 11. Here's what a Bohr model looks like. You make a nucleus and you're going to have rings. Now before we draw these, let me just make sure you know this. How many electrons did you learn in middle school go in the first ring? Up to 2. You can have less. 2's the most. Second ring, 8. Third ring, 8. Fourth ring, 8. Fifth ring, 8 if you need to go that far. 2, 8, 8, 8, 8, 8. Bohr models. Okay? So here's what happens. If lithium is element 3, he has 3 protons, 3 electrons, right? He's neutral. This guy has 7 protons, 7 electrons, neutral. 11 protons, 11 electrons, neutral. So the question is, what am I really worried about? Bohr models show where the electrons are. So I'm not really worried about the protons. Why? Where are the protons? They're right here. Here's the nucleus. All right, Bohr model for lithium. Ring number 1 holds how many electrons? 2. How many does he have? 3. So we're going to put 2 in the first ring. Now it's full. You can put them wherever you want, but there's going to only be 2. Ring number 2. Now remember, we said in another video, there's not really space here, but I'm drawing a space so that I can see it. It's a visual representation for my brain. Second ring can hold up to 8, but he only has 3. 1, 2, 3. That's his Bohr model. Okay? So when you draw one, you would then write the symbol under it. That's lithium. It has 3 electrons. Now what's going to be important is what happens to the electrons when they move around. We'll deal with that next, but we got to get our Bohr models. Okay? Nitrogen, 7. All right, here we go. First ring holds how many? 2. 1, 2. Second ring holds up to 8. If I had 8 plus 2 would be 10. That's too many. So I have 2 in the first, I have 5 left. 1, 2, 3, 4, 5. You'll even see people sometimes put 2 boxes just to show that there's 2 empty spaces. Now please hear this. Atoms don't have boxes floating around them. That would be 2 empty spaces because right now it's not full. Okay? Now, if you don't put the boxes, it's okay. All right? But sometimes either way is fine. But it has 7 total electrons, 2 in the first, 1, 2, 3, 4, 5. That's a grand total of 7. That's nitrogen. Got it. Sodium, element 11. There's his nucleus. First ring, 1, 2. Second ring holds how many? Up to 8. Well, I've got plenty. 1, 2, 3, 4, 5, 6, 7, 8. Grand total, 8, 9, 10. So I got to go to another ring. Next ring can hold up to 8, but I only have 1 left. Okay, so that's 11 total. And then I would label it sodium just like that. There it is. Bohr models are really easy. Okay, you're showing where the electrons are. That's very different from a Lewis dot. Okay, a Lewis dot shows only valence electrons. Only valence electrons. What are valence electrons? Electrons in the outside ring. Those are really the only ones that they are worried about. So the guy named Lewis came up with this idea and he said, well, if the rings on the inside are already full, why does it matter? Let's talk about the ones that are in the outside ring that aren't full. Okay? So he came up with a pattern, and here's the pattern. Okay? There's no element X on the periodic table, so I'm going to just use X to be silly here for a minute. Okay? He said you start at the top, and let's say something has 5 electrons in the outside ring. You would go 1, 2, 3, 4. You got to make it all the way around one time at the north, south, east, and west. So you're going around like a clock. 1, 2, 3, 4. This guy has 5, then I would stop. Okay? So if I had just an unknown element and I had 2 valence electrons, 1, 2, that's all there would be. If I had one that had 7 valence electrons, 1, 2, 3, 4, 5, start around 6, 7. So I made it around one time, and then I keep going until I run out. So let's do the Lewis dots for the 3 that we just had a minute ago. Okay? Lithium. So you're going to have the symbol. Now he had 3 electrons, but how many valence did he have? In the outside ring, he had 1. It does not matter where you put it, as long as he only has 1. I got a shadow on there. There it is. Okay, so he has 1 valence electron. It would not be wrong if you put it here. Okay, as long as he has 1. All right. Now, as I said a while ago, it's easier to follow the same pattern so you never get confused. So if you'll just start at the top, you'll be great. 1, 2, 3, 4, and then start pairing as you come around. So he has 1. How many valence electrons did nitrogen have? Well, nitrogen was number 7. There was 2 in the first 5 in the outside. So nitrogen, you put the symbol. Okay? And I have that where there's glare, so I'm going to move that right here. Nitrogen. How many valence? 5. 1, 2, 3, 4, 5. Lewis dot structures are very, very simple. If you know how to draw the Bohr models, these are very, very simple to go with it. Okay, last one was sodium. And I'm going to put it right here because there's no glare there. How many valence electrons does he have? Well, he has 2 in the first, 8 in the second, 1 in the last. Huh, he has 1 in the last. Who else had 1 in the last? That guy. Hey, check him out. Do yourself a favor. Check him out on the periodic table. You remember Mendeleev set up his periodic table where elements in the same column, what do we learn? They have the same properties, right? They have the same properties. They react violently or they do whatever. They do the same things. If you'll look where sodium and lithium are located on the periodic table, they're in the same column. How many valence electrons do they have? 1. All right? So let's do one that, real quick, we didn't have the Bohr model. If calcium is element 20, okay, what's his Lewis dot? Okay, so let's do the math in our head. First ring holds 2, okay, second ring holds 8, that's 10, okay, third ring holds 8, that's 18, so 2 and 8 and 8, it's 18, I'm trying to get to 20, so that means the last ring has 2. So calcium has 2 valence, 1, 2. There's his Lewis dot. If you wanted to draw the Bohr model, then you'd have the rings with 2 in the first, 8 in the second, 8 in the third, 2 in the last. That's how you would do it. So you got to read carefully. If I meet Bohr models, I sometimes ask you to draw these. They're easy. If I ask for Lewis dots, they're easy. If you need to draw the Bohr model to get this right, that's fine, but make sure you can draw a Lewis dot. Lewis dot structures are very simple, okay? Now, if magnesium is in the same column, and it is with calcium, how many valence electrons do you think it has? It has 2. These guys have exactly the same Lewis dots. Why? They're in the same column. That's why Mendeleev was so cool. All the things that he did made our life so much easier. Okay? So check it out. Lithium and sodium are in the same column. Hey, another guy, potassium, is found in the same column. So that means that lithium has 1 valence, sodium has 1 valence, and potassium has 1 valence. Okay? So there's lots and lots of patterns. As a matter of fact, we're going to get to a point where we'll actually learn what they call periodic trends. Things that you can look at the periodic table and it immediately gives you the answer. You don't have to go look it up. You can just tell and go 1, 2, 3, 4. You can count and you know the answer. It's awesome being able to use the tools we have to know things that we don't have to memorize, and it gives us shortcuts. So Bohr models versus Lewis dot.